Hello everyone, welcome to this tutorial on internal test 2 for introduction to data science. Unlike our first internal test which had computational problem, this test focus on conceptual understanding through fill in the blanks questions. We have four sections covering each data cleaning, machine understanding, machine learning concept, deep learning concept and method data Python data structure. Let's go through each questions and answers with clear explanations so you understand not just what goes in the blanks but why. Let's begin. So in the first we go. Yeah, so the first question is let's start with section A on data cleaning. The question number one is when merging data set with different measurement systems, ensuring a blank between unit is crucial. So the answer is consistency or uniformity. So think about it. If one data measure height in meter and another in feet, you can't just combine them directly. You would be comparing apple to orange. You must convert everything to a comma unit system first. So same with temperature, Celsius and Fahrenheit need conversation. Without consistency, all your mathematical operations become meaningless. So the question number second in data cleaning, blank out stresses that analyzes quality depends on input data. This is the famous principle garbage in garbage out. So this is the fundamental in data science. If you so in the fundamental in data science, if you feed poor data, messy or incorrect data into your analysis or machine learning model, you will get poor data result. No matter how sophisticated your algorithm is, it can't magically fix bad data input data. Quality data is the foundation of quality insight. So the question number three, systematic problems. So in the blank are systematic problems introduced during data cleaning progress. So that is the be corrected. So the answer is errors. So or bias. Here is an interesting point. Sometimes the data cleaning process itself introduce problem. So for example, you might consistency remove valid extreme value thinking, they are all outlier, or you might introduce bias through improper imputation. The good news is they are correctable if you catch them through validation. Now the question number four, irrecoverable information losing during accuracy like a power outrage. So it's called blank. So the answer is data loss or missing data or data corruption. So this is the different from data that never collected. This is data that was being collected but not got lost permanently due to system failure, power outrage, hardware crash, network failure. Once it's gone forever. You can't recover it. This is why redundancy and backup system are so important. So the question number fifth, replacing missing data with the mean of existing value is called blank imputation. So the answer is mean imputation. So this is one of the simplest imputation technique. If you have missing salary value, you might fill them with the average salary of all the employee. It's a easy implementation and maintain the same mean in your data set. However, the downside is it reduce variance. You are adding value right at the average, making your data less spread out that is really is. Now let's cover the next question. Continue with data cleaning. Fitting missing values are linear recursion or curve fitting is known as dash blank. So the answer is interpolation or predictive imputation or recursive imputation. This is also sophisticated that mean imputation. Instead of using a simple average, you are mathematically model to estimate missing value based on relationship and other variables. For time series for time series data, you might fit a curve through non-point and estimate the missing point, the prevalence pattern and relationship in your data. So the question number 7. Always preserve both the blank data and the clean data set. So the answer is original or raw or source data. So this is crucial. Never overwrite your original. Never overwrite the original. Or always keep it instead. Why? So first, you can verify your cleaning step. Second, if you make a mistake, you can go back and try again. The third, you might want to try different cleaning approach later. And the fourth, for auditing and transparency, always maintaining the raw data separately. So the question number 8. Converting John Smith or Smith John is an example of name blank. The answer is standardization. So standardization or normalization or formatting. Name standardization, putting name is consistent format, usually lowercase, last name first, removing titles like doctor or mister. This is essential when you are matching record from different database or removing duplicates. John Smith and Smith John and Smith John capital are all refer the same person, but computers see them a different string unless you standardize. So the question number 9, outlier detection. So in that, outlier detection is often used as a blank check. So the answer is a sanity check or quality check or validation check. A sanity check verify whether your data makes whether your data makes logical sense. If you see an age of 200 year or a salary of negative 50,000, sometimes clearly wrong. This is like data entry error or measurement problem. Outlier detection helps flag there as unreasonable value so you can investigate and correct them. And the question number 10, function like Unicode help remove inconsistency character during blank repair. So the answer is text or string or character or encoding repair. The Unicode function is super useful. It converts Unicode text to ASCII, handling special character, accent or diacritics and symbol also. So for example, it converts cafe to cafe and native to native. This is essential when dealing with multilingual data or when different systems use different text encoding like UTF-8, ASCII or Latin 1. So this all covered in question number 10. So now the question number 14, dropout or wet penalties are example of this blank method. So the answer is regularization. So regularization technique prevents overfitting by constraining model complexity, dropout randomly deactivating neurons during training, focusing the network to learn robust feature, wet penalties like L1 and L2. Regularization add a cost for having large weight, encouraging simple models. Both techniques force you model to generalize better rather than memorizing training data. So the question number 15. So training multiple diverse model to improve accuracy is known as blended learning. So the answer is ensemble learning. So ensemble learning is the window of crowds approach, combine predictions from multiple model to get better result than any single model. So the type includes begging, where random forest trend as many decision tree on different data subset, and boosting where xg boost and ada boost sequentially training model to correct previous mistake. Assembler are powerful but computationally expensive. So the question number 16. So in the question number 16, a simple reference model for comparison is called a display model. So the answer is baseline or benchmark model. So the baseline pro- provide simple comparison points. For regression, it might be predicting the mean value. For classification, it might be preventing the most common classes. A fancy deep learning model can't beat this simple baseline. This is not adding any value. Always establish a baseline before building complex model. Now let's go continuing with machine learning concept. So the question number 17. Independent unchanging data sample are described as blank data. So the answer is IID data. So IID independent and identically disturbed or static data. So IID assumption is crucial for many machine learning algorithm. It means each data point is independent, not influenced by other, and come from the same probability. Distributing the assumption is violated in time series data where today's value depends on yesterday's, or in sequential data like text where word order matter. Now the question number 18. Parameter turned before training and called blank. So the answer is hyperparameter. Hyperparameters are the setting you choose before training start. The control the learning process itself. The example, learning rate and in number of ports in neutral network, maximum depth and number of the uh, trees in random forest. The k main value is k nearest neighbor. These are the different from a model parameter like weight and biased, the which are learned during training. So the question number 19. In the question number 19, it's a comparison to various two version statistically and to see which performance better in blank testing. So the answer is A/B testing or hypothesis testing. So A/B testing compare two model version on the same data to determine which perform better statistically. So version A might be your current version and version B your new and improved version. So you need statistically test to ensure the difference is not just random change. This is standard practice for validating model improvement in production system. So the question number 20. In the question number 20, it's a normalization typically rescale numeric feature to rank blank. So the answer is 0 1. So 0 to 1 minimum maximum normalization scale all features to same 0 to 1 range, usually the formula x minus minimum divided by maximum minus minimum. So to ensure the feature we have equal importance in distance based algorithm and prevents feature with large value for dominating. An alternative is standardization, which scale to mean equal 0 and standard deviation equal 1. So the question number 21, the difference between train and test performance, measure, model, blank. So the answer is generalization. Generalization or generalization gap, it's indicate overfitting. The gap between training and test accuracy tells you how you well your model generalized to new data. A small gap means good generation. A large gap means overfitting. The model memorized training data but can't apply learned pattern to new example. Identically, both training and test accuracy should be higher with the minimum gap between. So the question number 22, biased sampling in data collected and cause blank bias. So the answer is selection bias. So sampling bias, selection bias occurs edge continue when your training data is not representative of the real population. For example, surveying only online user includes excludes people without internet. Training facial recognition on only one authentically collected data only during businesses hours. The result is model that perform poorly on unrepresented group. It's a major source of unfairness in AI system. Final question from machine learning concept: a model trained once and not updated further in is a blank model. So the answer is static or offline. So best trained model. So the static model are trained once on historical data and they deployed without updated. Think of traditional machine learning model that might be retained quarterly or annually. The risk is model statelessness and real world pattern change, the model becomes less accurate. This contrasts with online model that continuously update. So the question number 24, a model that continually retain with new data is a blank model. So the answer is online or incremental or dynamic or adaptive or continuous learning model. So the online model update continuously as new data arrive. They adapt to changing pattern, what we call concept drift. So the example include a recommendation system that learns from each click, fraud detection that adapt to new fraud patterns, and stock prediction that update with each market movement. So go to the next question. Now let's move to the section number C and on deep learning. So question number 26. Deep learning is a specialized subset of blank. So the answer is machine learning or ML or artificial intelligence or AI also. So understanding the hierarchy is important. Artificial intelligence is the broadest field, making machine intelligent. So, machine learning is a subset that learns from data without explicit programming. Deep learning is a further subset that user neutral network with multiple layers. So, AI contains ML and ML contains deep learning. So, the question number 27. So, neutral network. So, neutral network are universal blank dash of function. So, the answer is approximators. So this is the profound theoretical result called the universal approximation theorem. It states that a neutral network with enough neutrons can approximate any continuous functions to arbitrary accuracy. This means neutral network can theoretically learn any input-output relationship, making them incredibly powerful and flexible. So the question number 28. So the question number 28, a neutral network, not a neutral network, a network with more than one hidden layer is termed as black NN. So the answer is a deep neutral network or DNN. We clarify a network by depth. Shallow network have zero or one hidden layer. Deep neutral network has two or more hidden layer. Between input and output, more layers enable learning hierarchical feature in image recognition. Early layers detect edge. For middle layer detect shapes, and deep layer detects complete object like face or car. So the question number 29. Each layer output becomes the next layer blank. So the answer is input. That describe the feed forward architecture or neutral network. Data flow through the network is direction. So that input layer reverses data, processes it, and passes output to the first hidden layer. The layer's output become input to the next hidden layer, and so on until reaching the output layer. It's a sequential transformation pipeline. So go to the next questions. So question number the 30, CNNs are mainly used or blank classification. So the answer is image or visual or computer vision. So convolutional neutral network versionized computer vision. They are excel at image task. Clarifying image. Is these an cat or dog? Detecting object, where are the people, is the photo. Facial recognition, medical image analysis like tumor detection. This use a convolutional layer that detect spectacles patterns are feature while being translation invariant. So the question number 31, RNNs handle data and strong blank dependency. So the answer is temporal. So or sequential or time recurrent neutral network are designed for the sequential data where order matter. They are used for time series forecastings, stock price, weather, nature, class processing. Text is the sequence of word. Speech recognition, audio is sequential. Our video analysis, frame in time order or of memory through recurrent connections that feed information back into the network. So go to the next question, 32 to 37. So in this continuing with deep learning architecture. So LSTM. So the question number is 32. LSTM is an improved version of blank network. So the answer is RNN or recurrent neutral network. So short term memory network solve a critical memory problem with standard RNN as the vanishing gradient problem. Standard RNS struggle to learn strong long term net dependencies because gradient diminishes over many times steps. LSTMS use special gates, forgot gates, input gates, and output gates to control information's flow. This allow them to remember patterns over hundred of even thousands of times step. They are widely used for language model, machine translation, and complex time series also. The question number 33. In a GAN, the second model act as a blank distinguishing real and fake data. So the answer is discriminator or critical or judge. A generative adversarial network has a fascinating architecture with two completing model. The generator creates fake data trying to fool the discriminator. The discriminator tries to distinguish real data from fake. They are logged in competitions as the generator improve as creating realistic face. The discriminator improves at detecting them. The adversarial training produce remarkable realistic generate images and is used for image generations, style transfer, and data augmentations. So the question number 32. So the question number 32 ask reusing a pre-trained model for a related task is called blank learning. So the answer is transferred learning. So transfer learning is incredibly powerful for and practice. Instead of training from scratch, you task a model to pre-learn on a large data set like ImageNet and millions of image, and fine tune it for your special task. This model has already learned useful low level feature like edge and texture. You just adapt the high level feature to your problem. This save immense amount of time, data, and computations resource. So this fill in the blanks question takes your conceptual understanding of data science fundamentals. Make sure you don't just memorize the answer but truly understand the concept behind them. These are building blocks you will use throughout your data science career. I hope this was helpful for you. Thank you for watching, and don't forget to like and subscribe for more data science tutorials.